بسم الله الرحمن الرحيم. Welcome to Tahar Scholar. We are الأحد 29 أكتوبر 23 or in English Sunday the 29th October 2023. So we are still in our series programming with Matlab, which is an appendix for this module, and this is practical number 4 that continue dealing with the data type string. In this practical, we will see 3 sections. Section 3, string utilities. Section 4, formatted strings. And finally, section 5, a script where we apply what we have learned so far. So let's start our practical. So in section 3, we will see 3 main utilities. How to compare strings, how to find a string into another, and third point is a regular expression. Regular expression are a kind of constraints you must satisfy to find the string or a sequence of strings into another larger string in your text. So let's start with the comparison. There are actually 4 functions: str compare, CMP, str compare, str and CMP, and the same name but with I, means that the comparison is case insensitive. So str CMP A, it compares the 2 strings regardless of the letter is uppercase or lowercase, and str and CMP I. So we start with str CMP, string comparison. Let us first prepare our data. I copy paste. So we have 2 strings, S1, this is an apple, and S2, this is an orange. And these 2 strings, of course, are not the same, are different, because here they contain 2 different fruit names. So let's check str CMP, and as argument we give the 2 string S1 and S2, or S2 and S1, it doesn't matter. And if they are equal, it returns 1, that is true. And if they are not, it returns 0. So it returns 0 because they are not, of course. Now let us compare the first 10 characters. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. From T, N. This is N. So these first 10 characters are the same in the 2 strings. So how we do that? We use the version with N. str n CMP, and as argument we give also S1 and S2, and then we give N, the number of characters, the first number of characters we have to compare, actually in octave of bytes. The first 10 bytes we want to compare. So let's say 10, and here it should return true. So 1, yeah, it should return true because they are the same. If we do, for example, 12, it will return false because here A and O are different. It will return false. Let us try now uppercase and lowercase. Let's say S1. I repeat S1. Okay, but with capital letter T or uppercase T, not small case, lowercase. So this is an apple, okay. And let's compare the first 10 characters. It returns false. It returns false because big T is different from small t. So let's use the version with I. We get true. It doesn't matter if T is big or small, lowercase or uppercase, doesn't matter. So that's for comparison. It's very easy, very simple. Let's now, as I said, and I want to emphasize that with this data type, that we can manipulate not only ASCII characters. We are in 2023, and we should also be able to manipulate characters from other languages and symbols, emoji, etc. So let's copy-paste another sample of strings that contains characters outside the ASCII. So I have here A and B. So the string A contains alpha equal 10 degrees and beta equals 0.5 pi. And B, exactly the same, but not 0.5, just pi. And let's compare them. Of course, they are not equal. So we do string compare, and here it will compare the bytes of, which is the same thing, because a character is stored in 1, 2, or 3 bytes. If two characters are equal, they have exactly the same number of bytes and the same value in the bytes. So let's compare A and B. It false, of course. They are different. But let's compare now the first, how many characters here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's compare and the space. Let's compare the 13 first characters. But remember, a character is not an element, necessarily an element of string. Here, a character can be represented in 2, 3, or 4 bytes. We know that alpha, degree, and beta are represented in 2 bytes. So we have counted 13 characters, and we add 1 byte here, and 1 byte here. So 1 byte for each characters outside the ASCII. So let's do that. Compare, string and compare. We compare the first n characters, and we should give the number of bytes, not the number of characters. So 13 plus 3, and it should return true. As it has compared the characters, the first 13 characters, but we have added 3 bytes because alpha, degree, and beta are encoded in 2 bytes. That's it for comparison. Let's move to the second point, how to find a string into another. So let's clear our console and the memory. So let's write S equal this is a fruit. So this is our sample, and we want to find the string is. Here you find it here in this and in this. How we do that? We use a function called string find. So string find, str find, and it returns a row vector containing the indices where the string is found in the main string, in the first string. So you give 2 strings: the string where you are looking for, where you do your search, and the string you are looking for. So we are looking for is in S. This is the container where you perform the search, and this is the string you are looking for. So we are looking is in this string S. And it normally return the index here, where we find the first is, so it is the 3rd, and 4, 5, 6, and the 6th, normally. So let's do that and display the vectory 3 and 6. So the first occurrence is at the third byte and then at the sixth byte. Or here, byte and character are synonym because we are using only English letters, so ASCII code. Let us do now with another string that contain characters outside the ASCII. So let's also do a copy-paste. We have A, and we are looking for 0, for the character 0 in the string A. So J equal string find, with the keyboard, string find. We give the string A, and we are looking for the character 0. And we display J. So here we should find it at 1, 2, 3, 4, 5, 6. It's the sixth character. And then 7, 8, 9, 10, 11, 12, 13, 14. It should be the 14th character. But as I said several times, characters are stored as bytes. So you will see the number now. So it is 7. It is the 7th byte. Because here it is 2 bytes. So 2, 3, 4, 5, 6, 7. It is the 7th byte, the first occurrence of 0. Then we continue 8 and 9 because degree is stored in 2 bytes. 10, 11, 12, 13, beta also for 14, 15, 16, 17. So if we count alpha in 2 bytes, degree in 2 bytes, and beta in 2 bytes, we find the correspondence of the indices. So this is the start of the character 0 in our string, but the count is on bytes, on number of bytes, not on number of characters. And that's it. It's very simple how to find a string into another. Let's move to the third section, regular expression. So we clear also and the memory, and we start fresh. A regular expression is actually a standard technique to look for a string into another. But we don't give the string itself. Instead, we give a pattern, a set of constraints that that string we are looking for should satisfy in order to be considered as an occurrence in our string, in our main string, or our text, where we are doing search. So let's give first of all, let's prepare first of all our sample. It's a large text containing fruits. So I like fruits, and they are expensive here in Malaysia, in Algeria also. So let's copy paste and come back. So let's copy paste. So we have S1, S2, S3, S4, S5 containing fruits: apple, apricot, avocado, banana, blackberry, blueberry, cherry, grape, kiwi, mango, orange, peach, pear, pineapple, plum, pomegranate, raspberry, strawberry, and watermelon. And we concatenate them in a big string fruits. So fruits, we can display it. As you can see, it's a long string. Our task here is, for example, as an example, our task is to find all the fruits whose names start each with 4 to 5 lowercase. So the match we are looking for is start with 4 or 5 letters, lowercase letters. So all the letters are here lowercase. So let's say with 4 or 5 letters. And the word should end with berry and with the character berry. For example, blackberry, a blueberry, strawberry, a raspberry. How we can do that? How to find all the words that start with 4 or 5 letters and end with berry. Okay, let's remove this. And the function to do this task is called regexp, regular expression. In regular expression, we first give the string where we are doing the search, which is fruits. It's our text. And then we give the pattern. And what it returns, I come back to the pattern right now. It returns two vector of indices, I and j. I contains the start, the index where the word that has been found start, and j contains where that word ends. So the start and the end for each word found. So that's why they are vectors. We will see them, we'll come to back them later. So what is how we write the pattern? First of all, we give a set of letters from A till Z. That is in the range AZ. Our characters, the word must start with a character that is in this set. It can be A, B, C, D, etc. till Z. And how many times? It must occur minimum 4 times and maximum 5 times. How we do that? We use what they call occurrence quantifier inside parentheses, braces, I mean. This is a standard way. You have to learn it. If you don't know a regular expression, this is just an introductory, but you have to look in documentation on regular expression, tutorial on regular expression, to understand more carefully, more thoroughly this topic. But here I give just examples how to use it in Matlab or in Octave. The same, so the same, of course, same function. The pattern, how to write the pattern is standard in Matlab, in C++, in Java, in Python, in any language that has the ability to manipulate regular expression. So first of all, we have given the set where the letter must be, and then the occurrence, how many times? 4 and 5. Minimum is 4 and the maximum is 5. And they must be between braces. And then it ends with berry. And that's it. We type enter and we display I and J. I and J. So here, the first word starts with 30 and ends with 39. The second word starts with 41 and ends with 49, and so on. So I contain the start of each word, and J contain the end of each word. And here it's very important to notice that regular expression, regexp, this function, regexp, support only ASCII code, characters in the ASCII range. It doesn't work with alpha or beta or I don't know, emoji or Egyptian hieroglyphs. It doesn't work. It works only with English, standard English, and some mathematical symbol. All the letters that are in the ASCII range. So it's input limitation. I don't know about Matlab, the official Matlab, but in Octave, if you give as input a string containing characters outside the ASCII, you will find weird results. And it is mentioned also in the documentation that it does not support yet for the moment in October 2023. Maybe in future, yeah, because when I started with Octave, it was horrible. 10 years or about 10 years ago, it was really horrible, full of bugs and very limited interface, particularly the graphical interface. But of course, it has greatly improved. So currently, regular expression works only with ASCII code. So here, the number of the number here indicates the position of the bytes or the characters, because characters and bytes are synonym when you are in the ASCII code. So let's print these strings. How we do that? We use a loop for. If you remember, in lecture, I think in lecture 3, I presented the algorithm of a bookmap, and in that lecture, I introduced the loop while, and I said that there are two loops, loop while and loop for. Loop for works with an index. It needs an index, while loop while needs a Boolean condition. So here the index, let's call it L. It goes from 1. This is the syntax. You have to give the index and where it starts and where it ends. So it starts with and it ends with the number of elements in I, in big I. So from 1 till 4, because there are 4 elements in I. So the first, the second, third, and the fourth. The loop will cross this vector. So, and what we do here, we display this, we call the function disp. Observe, I have to put a comma because I start a new command. Disp fruits. So it's a string fruits, but not the whole string. The string that starts with IL and ends with a JL. So if L equal 1, we get I1, that's 30, and J1, that's 39. So we get the string between 30 and 39. And then we cross the loop 4, we get L equal 2. So I2 is 41 and J2 is 49. We display the second word and so on. At each step, we display a string from its start till the end, from its start till the end, and so on until all the strings are displayed. So we have here fruits, display, semicolon, and we end for. Always and for, if, while and and for. Here our loop contains only one instruction. If you have several, of course, it's better to write them several lines. But because it's short, we have written it in one single line. And we type enter. And as you can see, we have all the words. The first word, BlackBerry, start from 30. It's the 30 from here, from the first. It is the 30th character or byte. And it ends with 39 character. And same for Blueberry, Raspberry, according to the indices in ing. So let's come back to our regular expression. We have here printed all the words that end with berry and start with 4 or 5 letters. Let's now another match, another task. So let's write it here, another match. Let's find all the words, all the fruits, all the fruits that have a given length, For example, a given length equal to 5. So all the words in the fruits that contain only five letters, like apple, but not apricot, not avocado, not banana, and so on. Grape, for example. How to do that? So again, the match all the fruits that have a given length. We use a regular expression. How to do that? Let's write it again. A regular expression. We give the string or the text we are looking inside, and we give our regular expression. We use what we call a class character, B. We use backslash and the letter B. I will explain what does it mean. And then the set of character A till Z, and then the occurrence, it must be 5 times, and then the class character B. So B means with the backslash twice, means the boundary of a word. It can be a space, a comma, an underscore, a point, anything that separate a word from the rest. So any mark, punctuation mark, or space that separate a word from another. We call that a boundary. If we write just B, it is a letter B. But if you write it twice in Octave, and I think also in Java, you have to write the backslash twice. But in C++, you write it only once, and other languages. And if you look in the internet tutorials, you will probably find only one backslash. But in Octave, you have to write twice, the backslash twice. Okay, and then, so our word must be separated from the rest of the text. It must contain a letter from A to Z, a lowercase letter, and this letter must occur 5 times. When you write only one number here, it must be exactly 5. But if you write 2, the minimum and the maximum, like we have done here, 4 and 5. If you write 5, it must be 5. If you write 6, it must be 6. So the length of our word must be 5. And then the boundary to that word. Very simple. Bounded at the left and the right, and it contains 5 letters. It's just you have to learn the syntax, because the syntax, the grammar, is standard. You learn it here with Octave or in any other language, it's the same. And we type enter. And we have I and J. So we have 4 words that satisfy this constraint, that satisfy this pattern. Let's display it 4. And as you can see, apple, grape, mango, and peach. And that's it for this section, the 3rd section. Let's move to the 4th section. So the 4th section is about formatted strings. In this section, we will see how we can print in a formatted way numbers, strings, and matrices. So let's start with numbers. Let's say M equal 125 and X, a real number, equals minus 0.125. And let's see how we can print these 2 numbers the integer and the real number in a formatted way. We use for that a function called printf. Printf, f means in a formatted way, and the first argument is the formatted string. It is here where you indicate how to format your arguments, and the arguments are m and x. So let's say, for example, we display integer equal integer or 2 points, percentage, 5i, and number, percentage, 10.3f. And we end our string with an escape sequence n /\n. \n means a new line. N alone means the letter n, but when it is preceded by backslash, it means a new line. We call that an escape sequence. So the format always starts with the percentage character and ends with the specifier. Here it is I for integer. And the second format, it ends with f. F means floating format. So we have two formats, one for m, the integer, and the second for x, the real number. We say that to the function printf that the width of the string containing the integer m should be a five characters, or more precisely, 5 bytes. And in the second format, we indicate that the width of the string containing the real number should be of 10 bytes. And then the fractional part should contain 3. There is a decimal point between the width and we call that the precision. 3 is called the precision. Is the number of digits after the decimal point. Is the width of the fractional part of the real number. So let's type enter and see. Yeah, as I said, we have here 5, so there is a space character, and then 1 and 2, 3, 4, and 5. The width is 5 characters. It is filled with the number integer 125, 1, 2, and 5, and the rest is a padding character, a space character. Is padded with a space character. And for the number, we have actually 10 characters. It is filled with the real number, minus 0.1 to 5, and the rest is filled with space character. And as you can see here, we have 3 digits in the fractional part. We will see how to print a real number with other specifier. It's not only f. There is not only f as a specifier, format specifier. We can use G and E as a format specifier. So let's see that. For example, let's write y equals 20.75. And we print it using 3 different formats, the same number. So the string format, the same number 3 times. In the first, we use the floating notation. So we use the floating notation. The percentage, always the format starts with the percentage. Here the width, we are not interested in the width. So it will calculate the width according to the number you give. So we escape the width, and we introduce the decimal point, and the precision 3, and F floating point. And then in the generic format, we should also start with the percentage. We use the specifier G and same decimal point and the precision 3. And we see the meaning of the precision for each specifier right now. And then the scientific notation, also percentage, 0.3, and E. So we use F for floating notation, G for generic notation, and E for scientific notation. With the same number, we will display it in different format. And the precision is the same, 333. So let's do that. And as you can see, we have forgotten a new line. So let's repeat it again. And we add a new line, the escape sequence N. Okay. So the same number, 20.75, with the fractional part containing three digits. Then the same number, but here the precision means the number of significant digits. We have 1, 2, and 3. We have 3 significant digits. 5 and 0 are ignored. So we have to round up 7 because the next digit is 5. If the next digit is 5 or greater, we have to round up. Otherwise, we don't change the digit. So it becomes 20.8. And as you can see here, 20.8. We have 3 significant digits. So the precision in the generic format means the number of significant digits. And finally, the scientific notation, it always takes the first significant digit in the whole part, There is only one digit in the whole part. It's the first significant digit. And then because we said that the precision is 3, it takes 3 number in the floating part. And add E appropriately. Here we have to divide by 10. So E01, E plus 01 means 10 times 10 to the power of 1. Because we have moved the decimal point in the left direction. It's like we have divided by 10. So to get the number back, we have to multiply it by 10. So 2.075 times 10 to the power of 1. So this is the scientific notation. Always in the whole part, there is one digit, the first significant digit. And the precision is given, here it is 3. So let us do that again, but with a number that is a little bit smaller. For example, Z equal minus 0.07518. And repeat exactly the same instruction, but with Z. And see what we get. So in the floating notation, we have 3 digits after the decimal point. So 0.75. And the next digit is 1. So we don't modify the last digit. We don't round up. So we get minus 0.075. In the generic format, we have 3 significant digits. So this 0 are ignored, are not significant. We start with 7, 5, and 1. But because the next is 8, we round it up. So we get minus 0.0752. 1 here becomes 2. For the scientific notation, the first significant digit is 7, and the decimal point is moved to the right direction. So we actually multiply by 100, by 10 to the power of 2. And to get it back, we divide it by 100. So we have minus 7 dot 518 times 10 to the power minus 2. When we multiply this number by 10 to the power of minus 2, we get this. We get the original number. And the precision, we said that it is 3. Yeah, we mentioned it that it is 3. So we take 3 digits after the first significant digit. That is 5, 1, and 8. And exactly what we have done. So that's it. Significant of the precision in the generic format means the number of significant digits. And the precision in the scientific or the floating notation means the number of digits in the floating part. And in the scientific notation, always the first significant digit is in the whole part. And it is the only digit in the whole part. And that's it, and that's it. Now for integers. For integers, we have m equal 125. We have displayed it above in the decimal format, in the decimal base. We can print it also in the octet and hexadecimal base. For example, printf, the formatted string, and m, the same m but with different format. And that's right here, integer, is we want to print our integer. The first format is I, integer, decimal, decimal base, then O, octet. Octet means the base is 8, and hexadecimal X, hexadecimal, the base is 60, and new line. And we type enter. And as you can see, this is the same number, but in different format. Now we can check, for example, the octet base, 1 times 8 to the power of 2, plus second digit, 7, times 8 to the power of 1, plus 5 times 8 to the power of 0. So we have 5, 7, and 1 in the base 8. We start with 8 to the power of 0 till 8 to the power of 2, 0, 1, 2. And we get the same, 125. And you can also check with D. D has the value 13. In hexadecimal, you have A, B, C, D, E, F that represent 10 till 15, respectively. So, let's do it. 7 times 16 to the power of 1 plus D. D, as I said, means 13 times 16 to the power of 0. And we should get the same, exactly the same number. So integers, we can display them in different base. But what about the binary? There is no specifier. Unfortunately, there is no specifier for the binary. But you can use a decimal to bin that we have seen before. I think, in the first section. Dec to bin. And we said that it returns a string. So how we display a string in printf? We use the specifier s. Print f, the formatted string, and this time we display m in its binary format using the function decimal to bin. And because the returned result is a string, we use the specifier s. So percentage s, integer, our integer, and as you can see in its binary format. And that's it for no, there is two important notes. Actually, we can give the width or the precision for integer and real numbers. The precision for real numbers only. We can give them as an argument. For example, we have a number y. Let's print it again. Print f y number in the floating format, but this time I don't give the width coded in the string itself. I want to give it as an argument. For that, I use star and then dot 3 f, a new line. And because I have here indicated star, I should give here the value of that star, the value of the width. For example, 12, and then y. So 12 is for star, and y is for the format that starts with the percentage character and ends with the specifier f. So the width or the precision can be, or both, can be given as an argument. So let's print here, for example, as you can see here, the string where the number is displayed has a width of 12. We can shorten it, for example, instead of 12, 8, as you can see. And same for the precision, for example. Let's say instead of 3, I put here, for example, 5. So the precision, the number of digits in the floating part is 5. And as you can see here, is 5. And this is particularly useful to observe because I have written that the width is 8. But actually the number here, if you count 3, 5, 6, 7, 8, if the width is equal to the width of the number or smaller than the number, then the default, the width that is given is ignored. And the default is the width of that number. For example, if instead of 8, I mistakenly write 3, for example, it's okay. It will be 8, because this is the minimum width. So this is for the first note. The second note, you can also add a padding character other than the space character when you display numbers, not strings. Strings you cannot add a padding character. Let us come back, for example, to our integer m, and we want to display it in hexadecimal. We want to display it in hexadecimal in this way: 0x, 00, and 70. If we use only x, we get only that. So we need a width of 4 and the padding character of 0, or 00, and we add in the string 0x. How we can do that? Very simple. Printf the string format and the integer. A new line, and here we write 0x, then the format x, specify x, and we give the padding character 0 and the width 4. And we get exactly as I've said, 0x, because I have written here 0x in the string. Then the format tells us that the width is 4, and the base is hexadecimal. and the padding character is 0. If we don't add 0, we get a space character. For example, here, if I remove 0, we get space character, the padding character. The character that we fill, the width, is a space character by default. If you want to change it, the only option is the padding character 0. You can't add another padding character. And it's very simple. You just add 0, as we have said. So this is the two notes important to add for numbers, that the width or the precision can be given as an argument, and that you can add a padding character, which is 0 when you display numbers, not strings. Strings, you cannot change the padding character. It's always the space character. Let us now move to how to print strings. So let's copy paste. Let's first clear the screen and copy paste. And as you can see, we have three variables, S, A, B. They are all strings. I have included here characters in the B and P, in the basic multilingual plane, that are not ASCIIs, and A and alpha. And the format, the specifier for strings, is always S. So I printed S, the whole string, and then S, one character, and one S, one character. For characters in the ASCII code, like small a, you can use also the specifier C. But it doesn't work with alpha. It works only with ASCII code. So you can also, of course, yes, specify the width. For example, our alpha, I want to display it in a string of 10 bytes. So what I do, it is stored in B, okay, and the width 10. Always the width is between the percentage character and the specifier S. And let's add here bracket to see the padding characters, and the string will be displayed between the inside the brackets, between the left and the right brackets. So, as I said, and by default, strings are adjusted at the right. So we have here 10 bytes. We have 10 bytes. This is 2 bytes, and here we have 8 space characters. Is padded with space characters. And the text is adjusted at the right, not at the left. If we want at the left, we have to add the hyphen before the width. So we add here like minus, hyphen, and it will be adjusted at the left. And the rest of the string is padded with the space character. Now you can try another text. For example, instead of B, we can write the following text. String, it must be a string because the specifier is a string, not a number. Should not give you a number, should give a string. For example, test. And it is adjusted at the left. Let us remove minus. It will be adjusted at the right, the default. So it's very easy to display strings using the specifier S. Let's move to the last point in this section, how we print matrices. So let's clear the console and the memory, and we need data. For example, a matrix A equal reshape. We use reshape to reshape a vector, and the vector is a sequence, an arithmetic sequence in space, starting from starting from -3 till 5 and contains 12 items. And we reshape it using 3 rows and 4 columns, so that the number of elements here is 12, which is equal to the number of elements in the sequence. We type enter, and A is displayed, as you can see. You have 6 digits in the floating part. I don't want this default format. I want, for example, just 2 digits after the decimal point. How I can do that? Printf will not work. Printf comes actually from C language, and it is limited to numbers, characters, and strings. It cannot display, it doesn't recognize a matrix. The number of rows, the color, it doesn't recognize that. But there is, fortunately, a function that transforms a number to string, num to string. And that number could be a scalar, a vector, or a matrix. Num to string. The first argument is the matrix, and then the format of each element. We want to display our elements, not like this. 5, for example, I don't want 5 digits after the decimal point. I want just 2. And I want the width to be 10. For each element will be displayed in a string of 10 characters. Here characters are also bytes, because numbers, digits and the point and plus minus are all in the ASCII here. So characters and bytes are synonym. So let's say percentage in the floating point, and the width is 10, decimal, and 2 digits after the decimal point. This is a string. I can display it. I can display it using function disp. And I get, as I said, except the first column, the padding character, the space is removed in the first column. And then you have 10 characters. And the padding character is always space. 10 characters. And 2 characters after the decimal point. So you can change that, of course. You can write, for example, a smaller little bit, 8, for example, and so on. You can play with the format in the way you want. You can use also, of course, scientific notation, for example, and increase a little bit, like 15 and 3, for example. You can do that. You can do that, of course, and you can play the way you want to display your matrix, the format you want. Observe here that num to string is a matrix, actually, a matrix of strings. Let's store it in S, for example. Let's store it in big S. In big S. And see its size. It has three rows. The last one, it has 3 rows, and each row contains 55 characters from minus till 0. All are characters because it has transformed numbers to strings, to characters. So to print it, we can, by rows, we can use, for example, for I equal 1 till the number of rows, so size of S in the first dimension, number of rows, and I call printf. I call printf. The first argument is the formatted string, and the second argument is the row of each string of S. So the ith row. So I and all the element in the ith row. And in the formatted string, the format for a string is S. So percentage S, and a new line after each row. And I finish the 4 with and 4. So I can do that like this, or simply just this. This will do the job, and is easy and shorter. But if you want to print by rows, you can do that, and you get exactly the same. So this is for matrices. We can display matrices not directly with printf, but with the function num2string. And that's it for this section. Let's move to the last section, the fifth section. So we are in section 5, and we will dedicate this section to practice what we have learned so far on the data type string. We have seen how to encode characters, how to build strings and concatenate them. Then we have seen some utilities and how to display formatted strings or strings in a formatted way. So let us suppose, for example, I would like to print an invoice of vegetables. I like vegetables with, for example, macaroni or rice, and I want to print the invoice of the vegetables that I have bought from the market. So let's see, for example, I have it here. Let's see here our vegetables: eggplant, tomato, broccoli, capsicum, mushroom, the corresponding mass in gram, and the price in ringgit, in Malaysian ringgit. And the invoice starts with the date. I have done that in the 22nd October, but we are now the 29th October. And the total price of our vegetables. And you can see also that the padding character here between the mass and the name of the fruit is not a space character, is at a point, so that we can easily see the correspondence between the name and the mass of the fruit. How we can do that? And that's the task we want to do in this section. So before to write, let's first analyze the problem. We need a matrix for our vegetables. So let's write it here. Let's call it vegetables. Vegetables. And in this matrix, we write the names of the vegetables per row. Each row is a name of a vegetable. So, for example, here, let's write eggplant. So this is our matrix. It is a matrix of 5 rows. I have forgotten here. We use semicolon. When we want to build a matrix, we want to concatenate by rows. We use semicolon, not comma. That's okay. So the first row is the eggplant, the second tomato, then broccoli, capsicum, and mushroom. And this will build a matrix of our vegetables. We need also to store the data corresponding to the mass. So let's call it masses. This is our data. We will build our script around this data. That's the first thing to do. Let's go to the editor. Let's copy paste here, take our data. So we copy, and as usual, we clear all and CLC. We can also add a comment. For example, let's say this is practical number 4, and it's about strings. And let's write, for example, the author by Tarjwad, and the player. It's always a good practice to add a little small comment. The comment, what you write in a comment, is ignored by Octave, by the interpreter of Octave. The program that executes your code is called an interpreter. It ignores the comment. The comment is for you, or for someone who reads your code. Maybe after several weeks, you could forget what it is about, what you have written in. What you have written in this code. So it's always nice to add a small comment. So we are 29th October 2023 in Kuala Lumpur, Malaysia. In Malaysia. Okay, and let's save before to continue. In our document, let's go to documents, numerical methods practical, in appendix A. And we have already stored the matrix 1. Here let's call it invoice. Invoice underscore, I don't use hyphen. Hyphen is not accepted in Matlab. In other languages, they accept that you introduce hyphen in your file name, but not in Octave or Matlab. So let's say 01, and it will add M automatically. Save. And we have our vegetables. Okay. A good practice before to continue our task is to check the data. If there is any error, we can check that the number of rows in the matrix vegetables, that is the number of fruits vegetables, so size of vegetables in the first dimension, the number of rows must be equals, and use 2 equal and 2 because it's comparison, not an assignment, equals the number of elements in masses. So there are as many masses as vegetables, and same with the prices. And then let's print the date. So because our task, first thing to do is to print the date. So we use printf. Printf. The first argument is the formatted string, and the second argument that we want to print is the date. There is a function called date in Matlab or Octave, and it returns the date, the current date. When you execute your code, it will print the current date, and it returns a string. So let's write it. Let's call it, for example, invoice. We want to print the date inside brackets and a new line. Let's separate the date from the invoice by 2 lines. So new line. And let's write here the format, as we said, for strings is S, the specifier, format specifier is S. And that's it. And then let's print our vegetables. How we can do that? We go through we need to come back. So new line, okay. We need to write vegetables, okay. And then we need to write the vegetable with this width. So let's say this is about 23. The width here from this, let's say big W equal 30 characters till here. For example, till here. We want the name to be in a string of big W, and we want our prices from here small w equal 10 characters. So from here and here. So we need the length here, so the formatted will be correct. And let's come back to our, let's save and come back to our code. So printf vegetables, the string, formatted string, and then the argument. Here the argument is vegetables into string, inside string. So S, and then a loop for that crosses the vegetable matrix with by rows. So from 1 till the size of vegetables and along the first direction. And we end 4 here. And inside the loop, we write a print, our function print. Printf. So the formatted string and what we want to print. Okay, let's come back. We want to print the name of the fruit in vegetables, then the mass, space, and then gram, and then the prices. So we have 1, 2, 3. Okay, let's write it. Vegetables, the row in vegetable is a string. So, and then the masses, the ith item in the masses, the ith vegetable, and then the prices. And we want them as follows. Big W for the vegetables, then we leave a little space, and then the mass without width. It is an integer, and then comma. As you can see here, the mass, space, and then gram, and then comma, and then the price. I have forgotten here gram, space, and then the price floating point. The width is small w, and the precision, let's say 2, in floating format. And then we add the ringgit, Malaysian ringgit. Let's check again. W, S, I, and G. So vegetable, and then the mass, the gram, comma, the price, and the rep. Okay. In the first edition of the code, we will not care about the padding character. We just write the name, the price, gram, comma, the mass, gram, comma, and then the price, and link it. I think it's okay. If you make a mistake, it's not a big deal. We can come back and correct. And finally, the total. Let's save it here, the total, equal the sum of all the prices. We have seen function sum before in the two practicals dedicated to matrices, and then we print it. It's a floating point, so printf. Here we have forgotten the new line, the escape sequence n. Okay, printf. What we print here, the price, the total price, total. Total. And it is, so write it total. We don't care about the width, but we care about precision and in floating format and the new line. Let's check again. Okay. So, the total, there must be a new line before the total. And we need also ringgit. Okay. Let's add ringgit, Malaysian ringgit, and a new line before you print the total. And I think that's it. That's it. Let's save it. And let's check again. We have our data. We check them. Let's add a comment here. Data. Let's add a comment here. The date. Printing the date. And here, printing vegetables. And finally, printing the total price, or the total sum. So, we have forgotten W. We have forgotten W, and we do not write W here. I made a mistake, a big mistake. We write here star, and we write here big W. So W will correspond to the first star for vegetables, and here we write star. And just before the prices, we write small w. And we have to introduce them here. Big W, we have set 30 characters. And small w for the prices, we have set 10 characters. You can, of course, modify them if you want later. So this should be correct. I have written the variable directly. This is a big mistake. So when you want to precise, to give, when you want to give the width or the precision separately, not coded in the formatted string, use star. Star, okay. I think everything is here. Let's try. If we make a mistake, we correct it. So we go to the button to run, and we run. It asks us to change to the current directory. Yes. And let's see what we have here. Oh, vegetable undefined near line 12. Let's come back to line 12. Where is it? Okay, it's vegetables with S. It's vegetables with S. And here also vegetables with S. Okay. And we run again. And let's see what we have here. Because we have not justified the name to the left. The default is to the right. So let's do that again. And we have forgotten here also to add new line. To add here a new line. The title vegetables must be in a separate line. And then the vegetables. And here, justification to the left. And we print it again. You do mistakes, it's normal. You are developer. Okay, that's better. But it's not what we, it looks like, but there is something missing, is the padding character. Yeah, as you can see, it's exactly, let's put that here. This is what we wanted, but that is missing. How we can do that? So let's come back, let's save, and come back to our code, to the editor. We need, after the vegetables, we cannot directly add a padding character. It doesn't work. We have to build a string containing the padding character. And let's call it pad string. It's between the masses and vegetables. Let's call it pad string. Pad str. Let's call it pad string. And comma. And in pad string, what we put, pad string. So we want to repeat the character point, which is a number, a matrix. It is a scalar, it is also a matrix. We can repeat a matrix. We know that in the practicals on the matrices that there is a function called repmat. So we call the repmat, repeat our matrix, which contains one single element, point, dot, and how many times? We need a row. So one row, and how many columns, how many times the character is. Well, let's come back. Here, it is the length of number of columns of our matrix of vegetables, task columns, the maximum number of characters in the vegetables is the number of columns of the matrix. So minus W, this is big W. All this is big W. So let's write it. Big W minus the size of vegetables are 2. If you see the vegetables, I think the largest is mushroom, is 8. So it is the number of columns in vegetables. For the other strings, a space character is added. It will not exceed, the number will not exceed 8. So we have size vegetables, W minus size vegetables, and we close the parenthesis and semicolon. And let's try it again. We have forgotten padding string should correspond a format. So we have the first here for vegetables, then S for padding string, I for masses. This is gram, this is not a format. Format always start with percentage. This is the floating for prices. And it has a star, so a small w and then prices. And that's it, Let's run it again. Let's save it and run it again. And see what we have. We have at the right, not at the left. we have make a mistake here. We don't need to give width for vegetables because the width is included in the padding string. So let's come back and remove the star. We don't have to justify because there is no width, and we don't need to give the big W because the big W is included in the padding string. We have repeated the same character W minus the number of columns in vegetables. That is the space. If we come back, that space. We have all this is W, all this is W. We have removed the name, the length of the name, and we have given that. We don't need to give the width of each name of the vegetables. We don't need that because it is included in padding string. So check it again. Okay, and save and execute. And voila, as they say in French. And this is what we generally do when we want to implement code and algorithm. We try to understand the problem, we write like a draft, and we implement it, and we make a mistake. We come back, we correct, and so on. Let me also show you here, it is a good occasion to show you how to use breakpoints. So, for example, I want to see pad string, the content of it, the value of it. So I will put here breakpoint just after padding string, and I execute. So it has executed all these variables till now, till here, pad string, and you can see here the value. Or we can go to the command window and we type, you see here it writes debug, it displays debug, we are in debugging mode. Let's write pad string and see its content. And as you can see, it contains the dot, the character dot repeated a number of times. So it's correct. And we can continue execute the command line by line. For example, using, so we have this one and this one. This is when we use functions. Step in is when we use functions. Here there is no functions, so we use this. So we print vegetables, and we can come back, see what is printed, vegetables, okay. And then we continue with the loop. We start with I equal 1. I equal 1, we print this, and let's come back. This is the first line. It contains the first row of the matrix vegetables, eggplant, its price, its mass, and then its mass. And the padding string is correctly displayed between the name and the mass. And you can continue, of course, I equal 2, I equal 3, I equal 4, etc. Or you can continue till the end. And it ends the debugging mode and continue the tasks in your code. So it's very simple, but really I rarely use that because the code we generally do with Matlab is very simple and it's very easy. So this is it. Please subscribe, push like button, and share with your friends. The channel is not well known in YouTube because the number of subscribers is still very slow. So please, if you like this video and the videos before, check a few videos, and if you like, please subscribe to help this channel. And see you inshallah next time with another practical. We are still in this series of programming with Matlab. We need probably, I think, 2 other practicals, and we finish it. And then we come back to our chapter number 1. So see you, inshallah, next time. Peace.